Hello. Good morning, Vancouver. Thanks to everyone on the team, Matt X, Felipe, JD, Shauna. So far, this has been a very unique and interesting experience, but it's been going great. I have the staff here whispering sweet nothings in my ear on one end and then broadcasting off this with Discord and everything else. It's actually kind of cool. I was a little hoping that this wouldn't be overly awkward, but so far I like this. We could do some great things here. So anywho, I'm Joel. You can't see me waving, but I'm waving. From Nomad Jamf, you may know me from a few things. So on the internets and other things is Mac Troll. In the hallway track, maybe we could talk about that. But we're here to talk about single sign-on for fun and profit. Something that Apple released a year ago, I think almost to the day. We're about a year ago at WWDC 2019. They talked about single sign-on extensions. And as of yet, there's not any of them that have really shown up. So wanted to get in and to do some cooler things here and kind of show you some of the specifics of where all of this is going. Plus do some really cool demonstrations of things that I don't think anybody else has seen before because these haven't really existed yet. So able to do this, but first a couple of the requirements. We don't have nearly as much time as I would like to get into the very depths and esoteric details of single sign-on extensions, but we do need to bring up a few things as to what you're going to need to have for them. Most of this is covered in, I did a session for Mac sysadmin last year that goes a lot more into detail, but I wanted to just recap it here a little bit for those of you that are just new to the single sign-on extensions and what they're doing and able to get into this a little bit more as well. Anyway, the first major component is you've got to be on iOS 13 or macOS Catalina. So anything released within now pretty much the last year has access to the single sign-on extensions. So that's the biggest thing. Second biggest thing is that the single sign-on extensions focus primarily on something called URL sessions. So this is a foundational object provided by Apple that if you're coding in Swift or Objective-C and using the foundation layer that Apple provides, allows you to make URL connections without doing a whole lot of code yourself. So that's really good stuff. And this relies on URL session because it effectively injects your code into that process. And this is how applications that have no idea that you are a single sign-on extension or even that anything is happening, you can kind of have your way with them. So lots of cool stuff there. Couple of things to keep in mind around URL session. Apple supplied URL loading system, obviously, used by Safari and most of the native applications. However, that still leaves some things out. If you are developing your own application, chances are you're probably using URL session if you're coding in Swift, Objective-C, or anything within Xcode. It's not a hard and fast rule, but you really have to go out of your way to not use it. However, there are some very relevant things that don't use URL session and as such won't actually be impacted by a single sign-on extension. Curl, all right, uses its own URL loading. So if you use curl from the command line, it will not trigger the SSO extension. Anything done in Python, for example, Python's got its own way of doing URL loading. You could, of course, do some Objective-C bridging and use the foundational layer. I believe people more robust with Python will tell me if I'm right or wrong. But otherwise, Python by itself, you're going to have to do a fair amount of extra work to be encompassed by a single sign-on extension. Chrome, not actually going to use it. Chrome uses its own URL loading system as well. And then finally, SMB. Keep in mind, this is only web-based connections. And specifically for the credential SSO extension, which encompasses Kerberos, you might think that SMB would trigger it, but it in fact does not. So again, it's only things that use URL session. Keep that in mind because we're going to show you how to abuse this a little bit later in this session. So again, a little more quick recap on the single sign-on extensions. There's two types. There's a redirect extension, which is primarily used for modern authentication, OAuth, SAML, those kinds of things. So those are in there. There's also a credential extension. This is typically used with Kerberos. The only one that's actually shipping, as far as I know, which is the built-in Kerberos extension on iOS 13 and macOS Catalina. That allows a password to be provided whenever you get a 401 access required or authorization required. And when you get that back from a web page, then the credential extension can come into play and do things. For the most part, and from here on out, we don't care about the credential extension. There's the Kerberos one that's built into the Mac and to iOS. I don't think we're going to see many more, just because that's kind of maybe an older view of doing things. So most of the new hotness with single sign-on extensions is going to be focused on modern authentication, OAuth, SAML, those kinds of protocols. And so that's going to be much more focused on the redirect extension. Now, there's two single sign-on extensions that have been announced that I'm aware of. If you're aware of more, I'd love to hear about it, because these things have been very few and thin on the ground out there, which has caused some of the confusion as to what these can do, what these can't do, how you can work with them, and things like that. A couple of weeks ago at their Octane conference, Okta announced FastPass. FastPass encompasses a couple of different technologies, but one of them, from what I understand, will be a single sign-on extension that allows the user to not have to re-authenticate every time. That's coming out, I think, towards the end of this year. I don't know that much about it. Go to the Okta pages to look at it if you want to find out more. The one that's probably a little bit more accessible at this point in time is the Microsoft Authentication Library, MSAL if you're cool, for Objective-C. So this works with Microsoft Azure and is currently in public preview. So you can go grab it. There's the GitHub link down there. You can grab that. Currently, there's a lot of caveats with it, in that you have to include the library within your application. It's only for iOS, and you've got some other things that you got to consider as you go through there. In the README, there's a bunch of the different pieces that you keep in mind. We've played around with this. It's pretty cool, especially since it can work directly with Azure, and you can start playing with it today. So if you are messing around in iOS and you wanted to see how a single sign-on extension works, go there. Since nobody's ever seen this on the Mac, we're going to focus this whole session on doing this on the Mac. And then I've got a sample project that you could actually use if you want to make one of these yourselves. So there you go. All right. How it works, where the magic happens. The easiest definition of what a single sign-on extension is pretty simple. It's a malicious actor in the middle attack. It's injection of URL changes in the middle of a URL session that's being called. You can fancy this up and figure out a different way of framing this, but at the end of the day, that's exactly what this is. And here's an example. So if you have all the requisite pieces in place, the correct version and all the other things that are in there, if you have all of that in there, and you hit a particular endpoint, in this case, some made up Okta endpoint with an authorization endpoint there, that will trigger your single sign-on extension. That's the white box with the two gold arrows in it. Once your single sign-on extension is activated, you will get told what URL was attempting to be accessed. You can then do anything you want. You could require Touch ID authentication. You could require them to dance in front of the webcam. You could actually connect to that authorization endpoint. You could do all kinds of things with that. I mean, there's some pretty clever things you could do here. But of course, with great power comes great responsibility. There's a lot of goods and bads to this, as we'll show as you go through there. So just because your single sign-on extension gets triggered by an app going to a particular endpoint, there's no requirement that you actually go to that endpoint. You could load the New York Times crossword if you wanted to, base your authentication off that or anything else, right? And those of you maybe paying a little bit closer attention to this and thinking about what it can be used for in your environment, you could easily use this to take over endpoints that have nothing to do with authentication. Because while the single sign-on extension is being targeted towards, passwordless authentication and not having to retype a password for a user all the time, really what you're doing is you're just snarfing URLs and then doing things with them. So some really cool things that you can do there. And let's get into this a little bit. So here's a little bit of a demo. We'll hide out the slides. So I've got a little application here that we've created. It's got a web view in the middle so that you're able to kind of just load URLs and other things. And what I'm going to do first is I'm going to disable the single sign-on extension. I can do this because this app is actually the host app from a single sign-on extension. And so they share some defaults that we can put together through there. And my single sign-on extension is explicitly covering ADFS. Since you have to put an Apple App Site Association file on the endpoint or the domain that you're going to be connecting to, I needed something that I could have that I had complete control over. And in this case, I've got an ADFS installation, and so I'm going to be using that with my single sign-on extension. So if I just load this without the single sign-on extension in place, you can see kind of a generic setup, username, password, whatever else. This is what you'd expect to find if you were doing any sort of logins on a web page or something else like that. So now let me do the same thing, except I'm going to enable the single sign-on extension. So now it's going to be mandatory to be used. And I'm just going to hit this load button again. And now you can actually see the single sign-on extension in action. My base app went out, hit that exact same endpoint. That endpoint then triggered the single sign-on extension. That single sign-on extension can do a lot of different things. In this particular case, we're actually just showing a little bit of a sheet that pops down. So now I can sign in here. User nomad.menu and my super secret password that I won't say out loud. So now if I sign in, I've got tokens, and I now have a little bit of a piece of UI that shows up that shows that I've got a new access token, refresh token, ID token. So all the OpenID Connect things here. So the beauty of this is once I've done this once, I've stashed those cookies, right? So when you connect to a modern authentication system and you type in a username and password, you'll typically get a session cookie. Depending on the identity provider, it could be good for an hour, could be good for 90 days, could be good for whatever you want it set up to be. As such, those cookies then get stashed in your web browser, and the next time you go to a page that requires authentication, instead of the user being re-authenticated and prompted for the username and password, the user can just use those cookies. So the browsers automatically add the cookies to the URL session. Cookies get accepted on the remote side. User gets authenticated without having to type in a username and password. So now that we've set this up once, I'm going to close out this window. We've got a little bit of a cookies window here that shows the cookies the single sign-on extension actually has. So just by logging into ADFS, I grabbed a boatload of cookies here, including some stuff from Microsoft Online, some other things that are all in here and now allow me to re-authenticate without having to type a password again. So I can just go right into here. I can load this URL again, and you'll see I wasn't challenged for a password. Instead, I got brought up with this, end result, which is the actual ID token that I was looking for. So this is the single sign-on extension in action that it gets called whenever that URL gets hit. When that URL gets hit, your code can then come up and do all kinds of crazy things. So let me give you a little bit more of a practical example here. I'll hide this app, and I'm going to launch PowerPoint. So PowerPoint, as you might see, so I'm signed in here. I'm just going to sign out. This is the magician passing the hoop over the floating assistant, right? So I'm now fully signed out. I can say I want to sign in. That brings up the Microsoft login. This is technically, I think, the HRD home realm detector or something else like that, that you can do this. So I can type in my username again. This is then going to have Azure go back to my ADFS instance to authenticate me. And if I hit next, you're going to see my single sign-on extension briefly comes up, grabs new tokens for me, and then actually signs me into this application without having to do any work. It's really kind of clever in that PowerPoint has no idea who I am, what my single sign-on extension is. All it knows is it's going to a particular authentication endpoint. And that authentication endpoint then triggers the single sign-on extension, which then triggers my UI, which then allows me to do pretty much anything I want with it. And a prime example of this, you can't really tell from this flow, and I only know this because I was writing a single sign-on extension explicitly to support this. But when Azure hands off to ADFS, right? Because Office 365 goes to Azure for authentication, looks up your username, and then determines who your IDP, daddy is, right? Where you're going to go to get authenticated. So that IDP in this case is ADFS. And with ADFS, usually Azure uses something called WS Federation, a particular protocol similar, but of course different from SAML, that allows Azure to authenticate to ADFS and validate the user and goes back and forth. In this particular case, the Azure is forcing an authentication with ADFS. When Azure calls ADFS with WS Federation, it says, make the user sign in again. And so when I first started doing the single sign-on extension, I was constantly getting prompted to authenticate. I was getting a little frustrated. However, since your single sign-on extension can do anything it wants to the URL, you can actually remove that parameter of the URL query. So Azure says, I'm going to go to ADFS and I'm going to sign you in. That triggers my single sign-on extension. My single sign-on extension looks for that specific process, and I can actually bring up the code here that we've got in this. Looks for that specific process to go on, which is this WF-resh, probably WFresh maybe it's cool and hip, and schemas and some other things. So this is the particular piece of the URL connection that requires you to re-enter your username and password. When I get that, I just strip that out and remove the entire process. So now my SSO extension can then become completely authoritative for this, send that URL to ADFS without requiring the re-authentication. I add in all the cookies. Those go just as normal session cookies, and away you go. So that shows some of the power that you can get out of a single sign-on extension. Again, was kind of originally designed, well, most certainly was originally designed for authentication and ideally requiring fewer password authentications for the user. However, as we've gone through this, the mind starts reeling at maybe all the other kind of things that you can do here. So while we're here, a couple other things I want to show you. I'll hide off some of this. Head down to the command line. So first of all, the magic starts because we've created that Apple app site association file. So if I just do ADFS, nomad menu dot well known. Whoops, I don't think I have it at the well known. I think I just have an Apple app site association. And if I grab that, so this is the file that actually links this particular application. Menu Nomad SSO UI. This is my Apple developer ID, and auth serve means it's a single sign-on extension. So this is the glue on that endpoint that puts this together. And then if I go over to system preferences, go to profiles, one enrolled in a MDM service, which is a requirement for this, has to be user approved MDM or better. And if I go down here, you can see that I'm grabbing a URL, ADFS Nomad menu, ADFS OAuth2 authorize. That's the OpenID Connect authorization point. And then here's an ADFS /ls. This is the WS Federation endpoint used for when Azure calls ADFS. So both of these I'm now authoritative for. My extension is listed here with my team ID. That matches the extension in the team ID that's actually in the Apple App Site Association that's on my endpoint. So with all of those things pointing in together, that's what allows me to actually authenticate the user and become authoritative for that URL. So pretty cool. I think this is probably the first live example of a single sign-on extension on a Mac being done. I've been playing around with this a lot to kind of plumb the depths of what can be done here. And there's some pretty interesting things that you can manage and do. So since we got a couple of questions and I've got 9 screens in front of me, this is pretty cool. I feel like Minority Report or something. In the channel, we got a couple of questions. Does the single sign-on extension allow for login to the OS? The answer is absolutely not. And that's part of maybe good, maybe bad. The single sign-on extension runs as the user, and I'll show you why that could be interesting or bad in a little bit. So it runs as the user. So there's no real way for it to be functional to the login window, which presents maybe other interesting problems or opportunities depending on how you look at it. Also can get kind of complicated if you've remoted into the machine, things like that. It is per user. Ideally, I think most of the single sign-on extensions will be using the user keychain to store these cookies and other things that it may be doing. So just keep that in mind as you go through. The cookies are cached, in this case, specifically within my SSO extension. That's kind of the point of having the SSO extension, is that the cookies, you can inject or remove them as you want to as those URL sessions are going out. So you don't have to have them leave. I'll show you the kind of demo code that I've got here in a little bit where you can actually inject them back into the web browser if you'd like those cookies to be more persistent in the browser itself. But otherwise, I think most cases you're going to want to keep them in the single sign-on extension so you've got complete control over them. So you'll be able to go out and to do things. Question on the Apple App Site Association file. Can it be hijacked? Well, if you don't trust SSL, there's probably a lot of other things that are going to go wrong. But there are some very specific SSL requirements on the Apple App Site Association file. Has to be with a publicly trusted URL, or excuse me, cert. So you can't just use a self-signed one, even if you have the Mac trusting the roots. It only uses, I think, the built-in trusted roots to actually validate this. So you have to be using something like Let's Encrypt in this particular case is what I'm doing. So it has to be publicly trusted. There's a few other caveats to it. But essentially it boils down to, if SSL is somehow hijacked on your system, then yes, the Apple App Site Association file could definitely be suspect, which is why I think Apple kind of put in a bit of the belt and suspenders that in addition to the Apple App Site Association file, you have to have an MDM profile that allows that. So there you go. All right, back to the slides real quick. That was the demo for there. So now that we know a little bit more about it and you've already begun to see some of the possibilities for the abuse here, let's go even further into some of the things that we can do. So as I mentioned before about the question about can you use this to log into the Mac, the SSOEs run in user space. So as such, once they're triggered, a user can actually kill the single sign-on extension. A user has any capacity to remove any process that's running as their own user. So in this case, you could full out kill the extension and prevent it from operating. What I've noticed, at least in my extensions, and I don't know what the commercial ones or the other ones will be doing, once you kill the single sign-on extension, it defaults to just allowing the original calling application to handle the URL. So it's as if your single sign-on extension wasn't actually engaged. All right, so the URL gets loaded just as it normally would. The app gets the reply. All of that happens. So if you're going to run this and you want the functionality of a single sign-on extension, you have to make sure that you need it to fail closed, right? Because if your single sign-on extension, for example, is trying to do device trust or something like that, which I think a lot of these will be doing, and your single sign-on extension wants to make sure that you have a client certificate or somehow have otherwise authenticated your user or your device before this happens, you got to make sure that any other device that's just connecting will fail if that device trust or something else isn't there. So you can't depend on the single sign-on extension just to do all the work. So an example of this, we'll go back to my little utility here, and I'm just going to delete all my cookies. So I'm going to delete all the session cookies out of my single sign-on extension, which means the single sign-on extension will get triggered. So if I load this up, now you can see single sign-on extension because that sheet has come down. But if I go down to the command line and I just do a kill all -9 SSOX, that's the name of the process, the binary that I have. All right, so it's not a sudo, it's just as a user, and I just hit return, you'll notice the single sign-on extension got killed and control over that URL load got handed back to the calling application. So again, if you're going to be using this for things like device trust and things like that, you've got to make sure that you fail in a closed manner. All right, that way you're not, allowing people to just kill the single sign-on extension and move on. All right, so But what if you want to do something maybe a little bit more clever? What if you have an identity provider, Azure, Okta, Ping, OneLogin, take your pick, and that provider has not provided a single sign-on extension. Instead, for whatever reason, they don't want to do it. Or you maybe have your own reasons why you'd like to do this. And you think at first, maybe it's a bit of a challenge because if you can't control the web page, that endpoint where you can put the Apple App Site Association file, how would you ever allow your single sign-on extension to be triggered in one of these situations? Well, if you own an endpoint, you can put an Apple App Site Association file on it. If you can deliver an app extension and a profile, so that means you've got some way of, MDM, Monkey, whatever else to put a package down. And you have a need that nothing else can solve, maybe you too can provide your own malicious actor in the middle attack. And this is a semi-practical example. I did briefly try to think if I could get a bounty for this, but I can't find a way where this could truly be used for evil, because you would have to have so many things in place, and a bad actor would have to have put in some form of MDM compromise in place before the rest of this could be done. But all of this kind of involves a takeover of an identity provider. And the way that you can do this, most applications, when they connect to OpenID Connect or SAML, they're really just grabbing, there's a metadata document for each of those protocols that defines the authentication endpoints and the other things, the logout endpoint if there is one, where do you change your password, those kinds of things. So there is a discovery metadata package here, and it's typically found at /.wellknown/OpenID configuration for OpenID. SAML's got a different one that's in there. Lists all the endpoints and everything else that you can do with them. And most apps that support OpenID Connect start here. So if you have a SaaS application or something and it's got a pull down for Azure, that probably means it's just hard-coded the discovery metadata for Azure. Many of them will have a custom option where you can put in your own, right? Especially if you're running Ping or something else that runs as a on-prem identity provider, you're going to need to have that. So what we can do is we can take that and we can have some fun with this. So in this case, this is the Azure MicrosoftOnline.com. This is their discovery metadata. And the particular place that we care about, where the magic happens, as it were, is this authorization endpoint. That's where the user actually begins the journey to get tokens. It's where they would provide a username and password. So what we're going to do is we're going to swap that out with one of our own. And setting up a whole identity provider seems like an awful lot of work, right? A lot of things that are in there that you have to do. So instead, we're just going to create a new metadata document. And we're going to be really lazy. And AWS API Gateway, I think, allows like 1 million connections for free. So we're going to build an entire identity provider, and I'm using air quotes. You can't see that, but air quote, identity provider, air quote, out of the API Gateway. And all we're going to do is we're just going to put that metadata document up there. And we don't have to do anything with it. We don't actually have to provide authentication, because since we own the URL in our single sign-on extension, we're going to be able to take control of it and punch it any direction we want to. All right. So if you were just running a normal plain Jane OpenID setup, for example, you would put in a configuration document, and here's the Microsoft one that would set everything up for Azure. Instead, what we're going to do is we're going to instead point that call, idpsudo.com, something like that, right? Some domain that you own, set it up in AWS, and you can set up an API gateway so that you can return the JSON and everything else that you need for this. And if you're even feeling a little bit generous, you can even do a 302 redirect if you want. I'll explain that in a little bit. So now, if you have this set up, and you've got the MDM profile in place, you've got the Apple App Site Association file on your API Gateway endpoints, you've got the document, the metadata document on there, all those pieces up there. When something tries to connect, it's going to read the metadata document, and it's going to see that it needs to go to idpsudo.com OAuth2 v1 authorize. That will trigger your SSO extension. However, you don't actually need to go to AWS, because once your SSO extension is triggered, you can go anywhere you want. So you could actually take the user back to Azure and have them sign in through Azure, grab the cookies, and then do whatever you need to with the return, send the tokens back to the calling application. The calling application won't have any idea whether it was your authentication system or Azure. It just knows it got tokens back. If it reads the discovery document, it'll find the signing keys. The signing keys, you could point to the Azure signing keys. So it can actually validate the token and it'll be 100% correct. So now you've been able to do some cool things. And if you really want to be nice, for any application that doesn't have a single sign-on extension, you can actually be very polite and return a 302 redirect that just sends the application to the Azure authentication page, at which point the whole rest of that OpenID Connect flow will follow exactly as you expect it. So if an application has the single sign-on extension, you can then do more things. If it doesn't have the single sign-on extension, you can then just send them on its way. So let's do a demo of this and give you some examples of how this works. So I've been using ADFS, but I've got now Azure via Jamf SSO. So if we go back here, I can show you this. If I do a curl HTTPS, and I've got to find the actual location, but I can show you first just the Apple App Site Association file, and we go Azure v1.jamfsso.com/well-known/OpenID configuration. This is my Apple OpenID configuration. I'll figure out the URL correctly in a little bit. This actually, Apple App Site Association. That's the one I was going to go to first. The OpenID configuration is buried deeper in Apple App Site Association. And so here you can see this is my file. This is what's gluing my little demo extension into this. So we've got that in here. So I can go back over here to the single sign-on UI and I can show you Azure via Jamf SSO. I can load this up and now I'm getting my Azure sign in here. It's running within my single sign-on extension because I've got all this other glue that's putting it together. I can now sign in this fashion. This is going to prompt me for my phone. I will smile into the camera for my face. 94. Shh, I shouldn't have said that out loud. And then I've authenticated and I've got tokens, and I can actually inject these tokens back into this web page. And here now I have an Azure token that's been done through that way. So some pretty cool things you can do here. If I load this up again, I'll give you another example. I can actually inject an entirely arbitrary URL back to the calling application. So I'm just going to click this Apple button and it sends back a 302 with apple.com as the redirect page. So some really powerful stuff that you can do here. All right, that was the demo of some of the abuse that you can do. What I just showed you, I've got a working example up, gitlab.com/mactroll/SSOE example, 2 E's in there, actually 3 E's in there. That's got all the source code for that. So if you want to play around, plus some instructions. Note, you'll have to have a couple of things, an Apple App Dev account, an endpoint, MDM, a couple other pieces in there that we've already talked about. So real quick, since I know we're coming up close on the time, biggest thing I want to tell you about troubleshooting is every time I've created a new single sign-on extension and installed it on a machine for the first time, whether iOS or Mac, I have had to reboot the device for it to take effect. I hope that's something I'm doing wrong, but every time I've always had to reboot once before the actual Apple App Site Association file is correctly loaded. So just keep that in mind. If you're pulling your hair out and things are going crazy, that's where it is. We'll cruise through this real quick. The most interesting thing here is the swikutil command. System library, private framework, shared web credentials, support swikutil. And I'll show you this real quick. So system library, private frameworks, shared web credentials, resources, and then swikutil in there. Is that? I always get this URL slightly wrong. Support, sorry, not resources. Support, swikutil. If you just run it, you get a kind of a help page. I don't think there's a man page on it, but you want to do show. And this actually lists if your Apple App Site Association was actually correctly configured here. It's even nice, they've got the colors on it so you can see red and green if it's good. So that's one of the things to do for troubleshooting. Also in troubleshooting, there's plugin kit that shows you if your SSO extension is even in there. Curl, like I've been showing you, is good for being used for a couple of things. When you're looking in the logs on console, you can search on app SSO and you'll see some stuff. You'll get a little aggravated because the URLs are trimmed. I don't know if this is for security or what, but dots get put in. So if you think you can just search on your domain, you can't, because the domain name gets munged into just 8 characters or something like that. So that's going to annoy you. So just search on app SSO and you got to troll through a lot of logs. So in summary, a lot of moving pieces to a single sign-on extension, as you've seen. If you control your IDP, you can make an SSOE. If you don't control your IDP, you may still be able to do some things. And as I've showed you with some kind of fun and games that you can do with Amazon API Gateway, for example, to quickly set things up. So with that, thank you very much. Thanks to the team, Matt X, JD, Felipe, Shauna, all that. So far, this has been great. I'm excited about this. So happy to take questions, as the little voice in my ear says I can still be here for a little while. Let me cruise through the Discord and seeing if there's anything else on here. So Eric is asking, if you strip out some of the parameters in that URL, do you lose anything? Not from, it's all up to what you want to strip out, but you get the entire calling URL with headers and everything else from the original application. So your single sign-on extension has the ability to take what it wants or not. So you can have your way with it. If I go here to the code and I go to the example, so this is what's up on GitLab. I can make this bigger. Here's a little README that you can see in there. And I can actually go in and show you the specifics of the code that's in here. With your entry point into this single sign-on extension, you get handled the full URL request that application was bringing in. All right. So when you have that, you get the headers. If a cookie is being sent, that should be included in the headers, right? That's how cookies get sent. I know that now because I've had to have fun with that. You can decide whether you want to handle this or not. You've got some outlets here where you can just say, hey, forget it. I don't care about this one. Move on. And then once you've gotten that, you can then go ahead and create whatever response you want. In this particular case here, when I click that button that just said Apple, I was sending a 302 response code with apple.com in it. You could absolutely send whatever headers, whatever cookies, whatever tokens, bearer tokens, anything else that you want in that response. That gets responded to that original calling application. And that calling application can then, it doesn't know the difference. There's no indication that SSL or anything else was compromised because the URL session said everything's cool. The calling application just knows I sent a URL request for, the authorization endpoint. What I got back was this, so I'll display it. And if I go back here, right, so if I, just load this up again, the calling application sent a request for, my authorization endpoint. So this is what showed up in here. I could change the headers, ignore the headers. I've just loaded that URL directly into this web view here so I could continue on with it if I wanted to. If I hit cancel, it just brings it back to the original application. So then the application will load up the same thing as before. If I load it up again and hit Apple, again, I'm just sending back the original application, a 302, with that in the headers. So the calling application doesn't know. You pretty much have complete control. Again, because you want to do this for authentication is the main part, but I think there's perhaps some applications here where as long as you can own an endpoint, you could do all kinds of stuff that are much far and above beyond what just authentication is as you go through there. So another question in the chat, do you need anything special like an entitlement or anything else? Absolutely not. So I'm just using a standard developer account here. It's not like some of the system extensions and things like that. You don't need any entitlements. As long as you've got the $100 account, you're going to be able to use that code and make your own single sign-on extension. Again, the big kind of caveat is you have to own an endpoint that you're going to be authoritative for. But once you own that endpoint, yeah, just a normal run-of-the-mill dev account will be just fine. So, yeah, we've had a lot of fun with this. It's very similar on the iOS side. The code is almost identical, and the setup and everything else are in there as well. Since we got a little bit of time, another question from Discord. The cookies are in the applications cache or the single sign-on extension cache? Great question. So depends on how you do it. Let me show you something. So let me load this up, and I could sign in through here. This web view, the cookies are specific to my single sign-on extension. Now, when I do a 302 redirect, I can actually inject those cookies back into the calling application. When a calling application gets cookies, it comes in a header that says set cookie or something like that, and it's got all the cookie bits in it. So if I hit this inject button after I'd accomplished something in here, I could inject those cookies back into the calling application. By default, with URL session on the Mac, the cookie caches are generally set apart, which is goods and bads. Frankly, I think this whole thing could have done easier with just cookie filtration, and you wouldn't have to worry about SSO extensions, and you wouldn't have to worry about nearly as many crazy things as you could do, because what most single sign-on extensions are going to be doing is just session cookie management, so that you're able to keep the cookies out of the original calling application. If I use this in Safari, for example, if I go back to my ADFS example and load this up in Safari, any cookies that I pick up here will not be transitioned back to Safari. I could, if I wanted to, using this inject button, send them back there, but by default, they will be separate. So with that, I think we're coming up just to the top of the hour. Yeah, we'll be handing off to the next speaker in a little bit. So if there aren't any other questions coming from there, could you link an SSO extension to the Open Directory record of a user to use it as an authentication mechanism for a user at login? Well, again, we get back to the SSO extensions aren't active at login. I have no way of showing them since they run as the user. I don't think I could even trigger them at login. I haven't tried that super hard, but I believe they get ignored if a user isn't actually running in there. Now, once your SSO extension is triggered, could you do things and look up some of the APIs? Yes. Keep in mind, however, that your SSO extension is pretty heavily sandboxed. So there's a minimal amount of things that you could do within the SSO extension as far as just randomly reading and writing things across the system. So with that, thank you very much. We're going to move over to Discord for any other questions, but have a great rest of the conference. Thank you, everyone.